Welcome back. Today we're going to talk about types of chemical bonds or ways that atoms can stick to each other. We need to start by just knowing what a bond happens to be, and it's a force that holds atoms together and it causes them to function or act as a group. Now, these forces occur because oppositely charged particles attract to each other, and normally it's a positive nucleus is attracting to a negative electron, or positively charged ions are attracted to negatively charged ions. We can measure the strength of these bonds by looking at the bond energy of that bond. Strong bonds have high bond energy and weak bonds have low bond energy, and that's the amount of energy needed to break that bond. Here we can see a graphic of positively charged nuclei being attracted to those negatively charged electrons, and since both of these atoms have those positive charges attracted to the negatives, they act as a group in a bond. The first kind of bond I'd like to talk about would be ionic bonds, and these kind of bonds are seen between a metal, that's the symbol for metal, and a nonmetal. Now, ionic bonds occur when electrons, one or more, are going to be transferred from one atom to the next. The metals give away electrons, they lose electrons, and then the nonmetals gain, which is why we see the two dots only on the right-hand side of symbol X, which is representative of a nonmetal. Because of that, there's now charged particles, and these opposite charges attract each other. That opposite charge is what creates that force that holds the atoms together and causes them to function as a unit. Now we call the positive ion, in this case M, would be called a cation, not cation, cation. They're positive. A mnemonic for that is cats have paws, and they're positive. And then anions are negative, N right here for negative. We can see in the actual example, a sodium atom loses its outside valence electron. It's one valence electron, and it donates it to chlorine in order to make the chloride ion. The two oppositely charged particles are attracted to each other. The next kind of bond would be covalent bonds, and those happen between two nonmetals. The nonmetal symbol is X. And we can see that the electrons are being shared. So that's the key phrase for electrons, is shared for covalent. If you recall, ionic was transferred. So these two atoms share the electrons. Because the nuclei is positive, you have a mutual attraction for this pair of electrons, which is what causes that bond. Here we can see the valence shell, and then this one has 8 electrons. This one also has 8 electrons. These are being shared. That shared pair of electrons and the mutual attraction from these positive nuclei is what creates that bond. Metallic bonds use something called the sea of electrons. These are, of course, going to be between metals, and these valence electrons of the atoms don't belong to any specific metal atom. Instead, they belong to the whole group, and then they can flow. And that flow is why we call it the sea of electrons, because in an ocean or in a sea, the ocean doesn't stay in one spot. Because they no longer belong to one atom, these can flow, and that's part of why we see conductivity in metallic substances. Recapping, you need to know that metals are going to be metals as far as atom type. Non-metal or metal to a non-metal will be ionic, and finally covalent is going to be two non-metals stuck to each other. You need to know these phrases. In general, we want to talk about conductivity. If we're looking at a whole sample, we need to know that metals are good conductors in the solid form and poor conductors in solution form. You should know that ionic are good in a solution form but poor in a solid form, and then covalent are 100% non-conductors. How you might see this on an activity is if you were given a list of formulas and we were asking you to determine the different bond type. So if I gave you lithium sulfide, 2 copies of lithium, 1 copy of sulfur, what you're going to do is you're going to look and find where these atoms live. Now, lithium lives on the left-hand side of the periodic table. Lithium lives right around over here, and then sulfur lives right around over here. Lithium, these are the metals, is a metal. Sulfur is a non-metal. Metal to a non-metal, that's an ionic bond. Nitrogen lives over here, and oxygen lives over here. Both of those are nonmetals, nonmetal to a nonmetal equals covalent bond. Zinc lives over in this region, so zinc is a metal. That's equal to a metallic bond. What you should have learned after watching this video is that there's three different types of bonds. A bond is a force that holds atoms together, causes them to act as a group. You should have also learned that depending on the atom type, that defines the type of bond. So metal to nonmetal is ionic, nonmetal to nonmetal is covalent, and then a metallic bond is just a metal by itself. And finally, you should know the phrases for electrons: sea of electrons, transferred electrons, and shared electrons. Hope that helps.